invite Audrey and Troy into the chat. Thank you very much for providing the last session of the event. I think it'll be super interesting to hear what you guys are up to as well. Are you sharing any slides, Audrey?
Yes, let me go ahead and share my slides. Why is it not sharing? Give me one moment here. Screen.
No worries. While that's coming up, I think the topic of data science is an interesting one and something I know nothing about. But obviously, from a CNDM point of view, looking at the pillar from anything data to anything storage and everything in between, this is definitely one of those areas that we want to share and shout about within the community. Okay, so there's the slides. Let me know, Troy, if there's anything you need to hand over later on, but I'll be sat there just watching for questions. And once you're finished, I'll jump back in when you're finished. But awesome. Thanks for joining.
Thank you.
No problem. I guess we should go live. Are we live?
We are live, yeah. Go right ahead.
Okay, awesome. Well, for that brief pause, welcome. My name is Audrey Reznik, and I'm here with Troy Nelson. We are from Red Hat, and today we would like to talk to you about data science as a managed service on Red Hat OpenShift. So first, we're going to introduce ourselves. I've already told you my name, Audrey. I have been, I guess, a full stack developer for the last 20 years within data science, probably for as long as that, even though they didn't call it data science in that time, but officially data science in the last 6 years. And I'm working on a product called Red Hat OpenShift Managed Services. And I'll hand it over to Troy.
Yeah, I am a software data engineer. I am a recent graduate out of UC Berkeley. But yeah, data science is a great field, and our platform roads is a great option, but very new to the Red Hat team.
Okay, so let's take a look at what we're going to talk about today. What we'll look at is a model's role in an intelligent application. We'll look at what are managed services and particularly who uses them. And you'll be surprised, it's not only data scientists, but a lot of other folks. We'll take a look at what managed services have to do with model delivery. We'll also take a look at where you can find managed services. And then Troy is going to give us a fabulous demo at the end of using Red Hat OpenShift Data Science platform and its managed services. So let me jump right on into a model's role in intelligent applications. Our discussion kind of begins with intelligent applications. In fact, that when you look at an intelligent application, it just is not one small deployed thing. It really is an entire distributed system in and itself with a lot of moving parts that are tied together in various ways. So if you take a look at the diagram that I have, I mean, you'll see the model code there in the center, but by surrounding it, you'd have things like data verification, data collection, configuration, feature extraction, all the way to serving infrastructure and monitoring. So because the data scientist model is just one small part of this large distributed system, when you start building a model, you need to think about how the model is going to interact with everything in this distributed system. So for example, how do you connect to a data source and obtain and curate the data that you want to use for your model? You could go ahead and build your own code and application to do this, but it is a lot easier to use an existing service. So with that, we're going to jump in and take a look at what a managed service is and how they're used by different personas in the model development lifecycle. When we take a look at the model development lifecycle, and I want to bring your attention to the green boxes, we have to take a look at the steps in the model lifecycle and also link them to personas that are associated with them. So when we take a look at setting goals, we're going to associate that pretty much with everybody who's going to be developing the product. but mainly the business leadership that are defining the goals and setting the metrics. We move on to gathering and preparing data, where we bring our data engineers in. And then we look at developing a model, where we're going to bring our data scientists in. We look at deploying the models in an application, where we bring a little bit of the data scientists, but more of our app developers or ML ops engineers. And then for model monitoring and management, again, we can bring in our data scientists and app developers or ML engineers. But I also want you to take a look at the very bottom. We have IT operations involved in all of that. Now, each of these steps could have a set of services which would help that persona within that step do their work. So let's dive in further into each step and determine what services would be required to create and deploy a model which would be part of this overall intelligent application. I'm going to move away from setting the goals and look at gathering and preparing the data. Data engineers are going to be working on gathering and preparing the data, and this could be done by a service to make it ready for data scientists to develop their machine learning models. So when they're gathering and preparing the data, they are looking at data storage, they're looking at data exploration, data prep, stream processing. When that data gets handed over to the data scientist and the data scientist starts developing the model, they're going to probably use some sort of integrated development environment or IDE. So which IDE should they use? Can Python developers or data scientists create and use a reusable and recreatable IDE environment? This could possibly be a service with various machine learning notebooks or libraries and packages that they would want to use. Once they've gone ahead and developed the model, they're going to deploy the model within an application. So this is where the machine learning models are going to start inferencing or making predictions based on the new data that they would have seen that we would have brought in earlier. Could we use a ready-made application that would allow us to deploy and monitor these models? So these are all really good questions. We have all of these steps and all of these things that different personas need to do. And as with any data scientist or machine learning engineer, it would be really great to have these ready-made services in each of these steps to use, but without the hassle of trying to incorporate them into your own platform, managing licensing and support. At Red Hat, we've created a data sciences platform with these very services or managed services that we're talking about, except that you're not on your own to find support for the managed services that we offer. So let's take a look at what this platform looks like. To help everybody gain context to where they are, I've kept the steps that we were talking about before, the gather, preparing data, developing the model, integrating the models, and model monitoring and management. And I'm going to build this infrastructure from the bottom up. So at the very bottom, you see the infrastructure, which is the Red Hat Managed Cloud Platform. And this hybrid cloud platform should offer a very consistent experience across either on-prem, public clouds, edge locations, and will be efficiently managed by your IT operations. On the very bottom area, we have the platform being provided either by Red Hat OpenShift dedicated or by Red Hat OpenShift service on Amazon Web Services. And initially for us, AWS is the public cloud for the launch of this platform. And we determined that our platform needed to be supported on a self-service hybrid multi-cloud platform that would empower anybody working on it, such as the data scientists, data engineers, and software developers, to be very agile and collaborative. And that's throughout the whole process without depending too much on IT operations for individual tasks. So if you need more memory, more CPU for a particular project that you're working on and building your container, you should be able to have that self-service capability instead of writing up an IT request ticket. And this hybrid cloud platform should have integrations with hardware accelerators, for example, GPUs, to help speed up your machine learning model development and inferencing tasks. And finally, this hybrid cloud platform should offer a consistent experience across on-premises, public clouds, edge locations, and again, be efficiently managed by IT operations. Let's take a look at the next layer, which we bring in our own Red Hat managed cloud services. So we provide our own core Red Hat OpenShift data science offering. In this case, it is called the Red Hat OpenShift Data Science Platform. and you have the ability to use Jupyter notebooks that would have TensorFlow, PyTorch, and various other images that you could pull into a Jupyter Lab environment to do your work in. And this also ties in, this Red Hat OpenShift data science platform. We affectionately call it ROADS, so you might hear that acronym slip out when Troy and I talk. It also ties in with other optional cloud services like Red Hat OpenShift Streams for Apache Kafka. That's going ahead to gather and prepare your data, and our own OpenShift API management service, which would help you with the model monitoring and management. So again, an example that we would have within our Red Hat OpenShift data science platform, other than being something that you could use, we have a managed service in there that is Jupyter Hub and allows you to create multiple Jupyter notebooks for your experimentation. Let's go on to the next layer. And this is what we call independent service vendors, or ISV managed cloud services. So for our partners, we include as a service software partners like Starburst and Anaconda. So Starburst is a fully managed service that you can use to access your data using Trino and an MPP SQL engine. So you have very fast access and flexible management of your data. So here, if you didn't want to use Apache Streams, you could use this other managed service provided by another vendor. You could go ahead and create your Jupyter create a Jupyter notebook to help you with your model construction, either using ROADS or the Red Hat OpenShift data science platform, or you could use what Anaconda has available. They may have some ready models that you might want to use. So let's go ahead into the next layer. And this is what we call our customer managed ISV or independent service vendor services. And they're going to add software partner offerings like Intel OpenVINO. So once you've gone ahead and gathered and prepared your data, say again with Starburst Galaxy, developed your model in Red Hat OpenShift Data Science, you might want to go ahead and integrate your models in application development and deploy them. So you could use Intel OpenVINO for that. Now, the work doesn't stop when your model is deployed. You have to continuously monitor and manage the machine learning models in production to make sure they are making the right predictions. And with that, you can use Red Hat OpenShift API management to help manage any of the APIs that you've created. What we want you to get out of all of this is a platform developed for the data scientists in mind, but also the data engineers, the ML ops folks that work with you, and of course, IT operations as a whole, that will allow you to easily go in and create and deploy your model with the benefit of using managed services that we help manage for you, so that you don't have to worry about getting everything into one environment, and that people can then be more successful in working agilely together. Now, one of the benefits, or largest benefits that we have as Red Hat, is that we have a large partner ecosystem. Now, I only mentioned a couple of the partners in the previous platform, and as a new release, we've only pulled in a few of our partners into that platform, but we have a large ecosystem that you can choose from, whether you're looking at something in data processing or databases, hardware acceleration, data governance and security, or even the AI ML lifecycle itself. You have the option to choose from a number of open source, or I should say Fortune 500 companies as well that are in the sphere. In addition, Red Hat and our hardware partners have also developed reference architectures and benchmark machine learning workloads onto our OpenShift platform to ensure that the services that we offer you will help you build very good models that you're going to be able to deploy efficiently. And with that, I'm going to hand everything over to Troy. Before I hand it over to Troy, he is going to demo this Red Hat OpenShift data science platform. And again, we mentioned that it is going to be running from within Red Hat OpenShift Dedicated, which sits on top of AWS. So that's just to give you context of where he's going to be launching this application from. and he will be talking a bit about gathering and preparing data and developing a model and then deploying it. So I am going to let Troy take control of the screen.
All right. So we are hopping right into Red Hat OpenShift Dedicated, as Audrey just mentioned, and we are going to go through a notebook, some notebooks that we have within a text-to-speech demo workshop. Within Red Hat OpenShift Dedicated, we have access to all of our projects. And within these projects, they have all of our deployments. If we look inside, we can see a pre-built application that has been deployed and is available as an API endpoint at a service port, and has the availability to send requests and get predictions. And if it was a text-to-speech model, get text from, get speech as well from. But if we go up to our app menu icon, we can hop into Red Hat OpenShift Data Science, which takes us to our currently enabled applications. So these are the currently installed and usable applications, but there's also the Explore tab with additional services that we offer that are not currently installed. And lastly, on these pages, we have resources. So these are tutorials, documentation, and other material to help you get started either with roads, with some of these services, or doing things like model deployment and model development. So what we're going to be using is the service Jupyter Hub. And if we go ahead and launch the application, we'll be brought into an option to select the notebook images that Audrey mentioned. And we have several standard images on the left here. We have PyTorch, TensorFlow, even standard data science. And if we click on the question mark, we can see packages included. Standard Python packages, matplotlib, pandas, numpy, things that will be pre-installed and ready to use. For this specific workshop, we are not able to use the PyTorch notebook. The image for PyTorch does not include audio functionality. So we can create a custom image to include our TTS package and the system requirements, and have that pre-installed and ready for us to use. There's a few more selections before we start our server. The container size, which allows us to increase the capacity and CPUs that we're using. And lastly, the environment variables, which in this case, we are specifying AWS access keys in order to take from our S3 bucket, which holds our data set. Our data set for this workshop is an LJ speech data set, which has recordings from a single speaker from a book, manuscripts. And so we can jump into this repo and get started and take a look at that data set. When we come into Jupyter Hub, we will come in with all of our projects here on the left. It's very easy to create a new one as well. If you have a Git repository, you can select clone a repository and get started with a fresh clone. We are going to use our text-to-speech repository, which has all of our folders and Python notebooks available to us. We have models and configs stored away. We have utilities, as well as separate folders for our phonemes, our data set, as well as the output. So like to keep things organized within our repository and these workshops. But if we start with the getting started here, this is a great introduction to Jupyter Notebooks. It goes over things like how we define functions and how cells work within the notebooks. And so if you're looking into this workshop, that's a great place to get started if you do not know Jupyter Notebooks. But we will continue on to our data exploration. To start off, we're going to import some of the required utilities These come from our config folders as well as some of our utils like text cleaners. We also have some other Python imports and pip installs to make sure everything is available. The S3 bucket I mentioned is here, which we are able to download from the Roads pilot bucket. And this is our function to go into our dataset folder and download all of the WAV files required. And they are stored here in the LJ Speech folder. You can see the metadata CSV, which is important, as well as the waves folder, which all of the data set is stored into. So to get started looking at our data set, we're going to define some configuration. As you can see, we have our name, LJ Speech, where it's stored, and the metadata. We have a model configuration here. This will be used in the next notebook as well, and I'll go into it then. However, this is important for the tokenizer in order to get phonemes, which we'll talk about right here. We can see the configuration has 13,000 files. We are in English, and some of the utilities we're using, the phoneme cleaners, that all comes from our imports. So if we take a look at what our data is and what one of these WAV files sounds like.
Printing, in the only sense with which we are at present concerned, differs from most, if not from all, the arts and crafts represented in the exhibition. Printing, in the only sense...
Hopefully you can hear that all right. This down below is actually the printed out version of that output. So this is the phonemes that is associated. And if I play it again, you may be able to follow a little along and maybe translate some of it and tell.
Sense with which we are at present concerned differs from most, if not from all, the arts and crafts represented in the exhibition.
But continuing on, taking a deeper look at these phonemes, we can see that there are 40 phonemes in this data set. That is an expansion upon the alphabet we are used to, and we have plenty of data to take a look at to see some of the more unique cases, the things we are not seeing. We see punctuation, J's, as well as some more unique letters, including theta. And if we take a look at the entire picture of all these phonemes, you can see the breakdown is massively in some of the more common letters here, while plenty of these lesser known, more unique, and split up sounds are characterized. So phonemes are a part of phonetics, which is a part of linguistics. And the goal is to characterize all sounds that humans can make or perceive. So it is a wide array of descriptors and very specific into which emphasis you're using and so on. So now that we've understand this data set, we can hop into model development where we're going to use that data to train our own model. So yet again, we're going to do our imports and configuration setup. This time we can take a look and see we have some of the parameters to define how large of a model we would like. We import the basic Glow TTS configuration, which includes many more parameters that we could specify, but it's great that they have it predefined for a working model. But we're all set to start training the model. We have to use our configuration to set up an audio processor, our tokenizer, and then lastly, a formatter. And with our LJ Speech dataset, we're going to define an LJ Speech formatter just so that our dictionary is properly set up for our trainer to use for the training data. You can see the formatter is included in our train test split. Our model includes the configuration and tokenizer. And last but not least, the trainer is set up, including all of its parameters that we could mess with as well. There are plenty of parameters in here, though, so model is plenty big. And for the magic, we can finally fit that model using the trainer, and we will get our step through and our epochs, and lastly, our outputted model when this is ran. And this model could then be used to output speech. You can use the terminal or functions to output speech with that model. Additionally, there are pre-trained models like the Glow TTS model that you can use. And so once we have a fully trained model, we can give it text and have it create output. So if we want to take a look at what we can output, let's take a listen.
My sprinkler goes like this and comes back like my spring.
Hopefully you can hear that all right. But yeah, that's fun stuff. But once we have our model fully trained, these last two notebooks shortly talk about how to deploy that model to an API endpoint using Flask, and then test it and send it text to be able to then output a WAV file and play that WAV file for whatever application or service you are looking for. And once that model is fully prepared and within a proper repo, you can come back to our Red Hat OpenShift dedicated, which, very similar to this application, could be deployed and very conveniently monitored and managed using this UI, where you could view it at a service port, at a website, whatever best option is available to you. But that just about concludes our model development and training and this notebook. So I appreciate the following along, and I hope that you guys can learn something and get something out of this. But I'll stop sharing and thank you.
Yeah, and I'll just go ahead and share my screen one last time. And just thank you for your time, and let you know that if you are interested in taking a look at Rhodes, you can try it for free. You can go to https://developers.redhat.com products, Red Hat OpenShift Data Science. We have a number of tutorials there as well. Troy's tutorial will not be there yet. It will be upcoming, so keep a lookout for that. But if you're interested in natural language processing, image detection, or I should say object detection, or just learning how to use a PyTorch or TensorFlow model, or even getting ready to jump into Jupyter Notebooks, we have it all there in various learning paths. So we would like to thank you for your time. And if there are any questions, we will answer questions.
I don't know about the stream and any questions there, but I have a lot of questions to ask about this. The first one from my point of view is how much or what needs to be backed up, and do you have any? How often does the terminology around backing up any of this data comes up? Like, we've found from a custom point of view that we're speaking to a lot more data scientists that have that requirement to protect workloads, and it's not the protection of the test data per se. It's actually more of the algorithm that's being protected. Is that something you like? Do you hear that? What you're doing? Like, how often do you hear about backup?
Yeah, so we have some clients where algorithms are very near and dear to their hearts. Really, at the end of the day, when you create one of these applications, everything is tied up within a container and it's very secure. There is security involved. When they're working in the notebook environment or the Jupyter lab with the notebooks that Troy was demoing, they're going to be saving their stuff in a Git repository. So it's up to them if they've made their Git repository public or private. Hopefully they've made it private if they're very concerned about their algorithms. Other than that, you can rest assured that we have had a lot of people using the OpenShift environment, and they have found it very, very secure.
Yeah, awesome. Yeah, I've still got loads of questions around that data management. But so there was no questions on there, but awesome session, super insightful into the world of data science and in particular around what you guys are doing from a Red Hat OpenShift point of view. Thanks so much for submitting the talk. I'm sure we'll see you again on another CNDM day. in the not too distant future. If there are any questions after the fact to any of the sessions that we've seen today, just drop them down into the YouTube comments, and I'll be sure to speak to the presenters, share that around so that we can get you the answers to that. But yeah, with that, Audrey, Troy, awesome session. Thank you very much. Yeah, brilliant stuff.
Thank you for having us.
Yes, thank you.